We have a guest with us today. Hello, Abby. How are you?
I'm good.
Good. And how are you, Miss Stewart?
I'm fabulous,
That's
Mr.
great.
Haas.
Here's a function. I'm going to find the derivative of it, and then the second derivative, and I'm going to use both of those things to sketch a picture of the original function. So let's find the derivative of
Let's
this function.
do.
Shall we, Miss Stewart?
Let's do.
So this is trivial at this point, of course. This is 10x to the fourth minus 12x cubed. Hopefully that's not a big deal at all at this point. I'm just using the power rule. So I want to find critical points, and of course critical points occur when the derivative is either 0 or undefined. This guy looks like I can set it to 0, and it looks like I can factor out an x cubed. Oh, I think I can factor out a 2x cubed. Let's do that. It's a tricky one. Not really. So that gives me a 5x minus 6. So far, so good, Ms. Stewart?
It's looking fabulous.
You checking my work?
I'm checking your
All
work.
right. So it looks like I'm going to have two critical points. 2x cubed equals 0, and I can pretty much figure out that one right in my head. I think if I put in a 0 here, I'll get 0. So x equals 0 is one critical point. And the other critical point, 5x minus 6 equals 0. So that gives me 5x equals 6, x equals 6/5. A little more than 1 is my other critical point.
Beautiful. Now, do I have to worry about looking to see where the slope is undefined with this one?
Ah, that's an excellent question. Well, it turns out, of course, that this function is not undefined anywhere. There's no x in the denominator. So the two critical points that I have are just places where the slope is 0.
So if there's no denominator in the derivative, you're pretty much good to go.
I'm just looking at 0 slopes here.
Fantastic.
That's a fabulous question.
Well, thank you.
Yeah, okay, so 0 and 6/5 are my two critical points. Now I'm just going to check values on this side of the number line. I like to put in like a -1. That sounds good.
Yeah.
And I'm putting it, I could stick it in this guy, but I'm going to put it in the most factored form of the derivative. So I'll put in -1. -1 cubed is a negative, times 2 is still negative. So I have a negative, and I'm just going to make a little note underneath, times, let's see, I'm putting in -1 for this, that's -5, minus 6 is another negative, negative times negative. I think that gives me a positive. So the slope over here is positive. I'll put in perhaps a 1. That's another easy number. 1 cubed, of course, is positive, times 2 is positive. Do you keep track underneath like that, Ms.
I
Stewart?
do.
Oh, that's great. So let's see. Move it over a little bit. So that gives me 1 times 5 is 5, minus 6 is a negative. Positive times negative is negative. I think I can guess what the next one's going to be.
I can guess, but you never know.
I'll put in a 2. That's going to be a positive. And that's 10 minus 6 is also positive. I mean, you know, of course, by now that it doesn't have to alternate like this. It certainly could have been positive, negative, another negative. You never know. But these are the slopes. These are the slopes of the original function. The original function goes uphill. It has a slope of 0 here. And it goes downhill. Then it goes uphill. So I have my two critical points. Abbreviate. Critical point at x equals 0. And x equals 6/5. And I have a relative maximum at x equals 0. It's pretty obvious that that's a maximum. I have a relative minimum at x equals 6/5.
Well done.
Thanks. So here's the same function. I just erased a little bit to give myself more room. I want to find the inflection point or inflection points on this function. Now I can kind of eyeball it. I think on this one there's going to be an inflection point somewhere between 0 and 6/5, somewhere in this region. It looks like I'm changing from concave down to concave up. But of course, to actually find the inflection point, I need the second derivative. So that gives me 40x cubed minus 24x squared.
36
Thank you
x
very much.
squared.
I'm glad you're paying attention.
Yeah, well, it's Friday afternoon, you know.
Okay. 36x squared, and I think I can factor out a 4, so let's do that. I'm setting it equal to 0. I can factor out a 4x squared. Obviously, you're going to have to pay close attention to my
I
work
am. You're
here.
doing an excellent job,
Thank you
Mr.
very much.
Haas.
So that is a 10x minus 9.
Fantastic.
Set each one to 0, so it looks like x equals 0, right? If I put in a 0, I get a 0 here. And x, I'm going to do this in one step.
I go for it.
I'm going to add 9 to both sides and divide by 10, so 9 tenths is my other possible inflection points.
Possible inflection
Possible
points.
inflection points.
Yeah.
That's a little bit different. You know, when you take the first derivative and set it to 0, when you find the zeros, the places where x is zeros, those are guaranteed critical points. You don't know whether they're maximums or minimums, but they're guaranteed critical points. Here, you don't know whether these are inflection points. You just know that the concavity is 0 here. So I'll make a little sketch. I know I don't have a whole lot of room, but I think I can handle it. 0 and 9 tenths, and you said I wouldn't have enough room.
I know.
Yeah,
Crazy
right.
me.
So I'll put in a -1, and pretty much I can tell anything I put in here, I'm squaring it. That's going to be positive. Times 4, it's definitely going to be positive. I'll put in a -1 for this. That's going to be negative. Positive times negative is negative. I'll put in what should I put in? A 1/2? How's that going to work?
I think that will work just fine.
Again, it's going to be positive. 1/2 of 10 is 5, minus 9 is negative. Positive times negative is negative.
Oh, very
So it's
interesting.
concave down here. It's still concave down on this side.
Ah.
So this is not an inflection point at 0.
Right.
I'll put in a 2 here. Why not? Positive. That gives me 20 minus 9. Positive. Positive times positive is positive. So in fact, the concavity changes here at 9 tenths, so I only have one inflection point. So I have my critical points, my relative max, relative min, and I do have an inflection point at x equals 9 tenths, and that's the only inflection point I have.
Yeah.
And again, you can kind of look at the thing.
Yeah, that totally makes sense given your sketch.
Yeah, I mean, it certainly looks like it's concave down till about right here, 9 tenths. That's almost 1, and then it kind of goes concave up like that.
Well done, Mr. Haas.
And there you go.